In this video, we are going to proceed with measure of dispersion. However, we are not just going to talk about measure of dispersion alone. Yes, we start with measure of dispersion, but later, in order for us to explain the value of measure of dispersion, we are going to also need to include MCT, right? Because that's how we use measure of dispersion, right? We explain about the spreadness, right? The range of the data by comparing it to the MCT value. Okay, so what is MD again, right? It describes the degree or to which a set of data tends to spread around the mean value. So the calculation, right? The calculation of measure of dispersion is actually when it talks about spreadness, it's actually talk about the spread. It should compare it with something, right? So for measure of dispersion, it compare the range of each data from the mean value. Okay. Okay, so later by looking at measure of dispersion, we're able to see whether the data set is focused around the mean or scattered around. So in other words, just imagine that if maybe you calculate the average of CGPA, right, for your class, and later you find the dispersion and you'll see that the value is small. So basically we can say that the data set focus around the average. So in other words, we can say that most of you guys, right, CGPA of you guys is actually around the mean. So you guys have similar CGPA among each other. However, if the value of MD is high, so we can say that it is scattered around, not near to mean. In other words, some of you might have higher CGPA compared to the average CGPA of your class, and some of you might have a lower CGPA compared to the CGPA of your class. Maybe we are going to look at a figure later to be more clear about dispersion. So this is the kind of measure of dispersion that we have. The first one, the simplest one, is known as range. This is where you subtract largest value to the lowest value. So just find the largest value in your data, subtract to the lowest value of data. Hence, that range will be used as to measure the dispersion of your data. Okay. However, range here is actually we rarely use range because it is too sensitive with outliers, and it did not really take into account other data. It just used two data, largest and lowest. So it is not really a good way to portray the spreadness of data as a whole. Okay, and then we have variance and standard deviation. For these two, okay, they are actually among the measure that we use to look for dispersion until now. Okay, we are not using both. Variance is actually denoted as S squared, and standard deviation is denoted as S. Right, this is for sample. So if you realize standard deviation, to obtain standard deviation, you will need to do square root from the value of variance, because variance is S squared. So basically, right, to look for dispersion, this is the true value that we look at later, right? To explain the spreadness of data, we're going to look at standard deviation. However, to look for standard deviation, we'll need to calculate for variance, because standard deviation comes from variance. So either you want it or not, you'll need to calculate both, right? And then we have interquartile range, which also talk about spreadness, right? But it's actually it is kind of range where you subtract between two values. However, the value that being chosen is not largest to lowest value. It is the value of two quartile, right? We're going to talk more about how to find quartile later in measure of position. So they are using two quartiles, and then that two quartiles will be used to describe the dispersion. Okay. So this is the formula. Okay, you have the formula of range, and you have formula of variance and standard deviation. Don't be worried too much. As I said, everything will be calculated by the software. However, you will need to know how to interpret the value later, right? And for IQR, it is Q3 minus Q1. Okay, so this is the formula for ungrouped data, right? Which is the raw data. Okay, which is this kind of which is this kind of data, right? You have a raw data. However, if you have a data in a frequency table, it is a group data, and you can't really use the this formula. Okay, so if your data is a group data or in the form of frequency table, you will need to look for this formula, right? This is the formula, right, for standard deviation and variance for group data, right? If you realize, they don't have a formula for range and IQR, because for range and IQR, it can only be used for ungrouped data. Okay, so we're going to see about the dispersion a bit later. Now let's look at this. How can you describe, okay, a data, right? The dispersion of the data just by looking at this kind of graph. So as you can see, this is they give you two graphs, okay, right? This is the characteristic. If the graph, if you try to draw it, and you try, let's say, a histogram, and you try to find its shape, and it's shaped like this, where the spreadness is, you can say, this thin, right? And however, and the peak is high, right? We can say that the dispersion is small, right? Because most of them accumulate here. Okay. However, right, for the second one here, the spreadness is larger compared to the first one, which is, we say it has a wide dispersion, and with respect to that, the peak is also lower, right? Because a lot of data spread at other places, right? So if you look at this, right, this blue one, right, if you look at the legend here, the standard deviation is 1. As for the rate distribution here, the standard deviation is 1.5. So we can say that the spreadness of the blue one, the distribution of the blue one, is lower, sorry, compared to the red one, and lower in terms of what? What do you compare it with? From the mean value. Okay, so this is a situation where these two distribution is having different dispersion, but same MCT, same mean, right? This mean in the middle. Now in the next case, we have, right, the same, not the same actually, we have a similar distribution of the first one and the second one. However, as you can see, they are not in the middle. For this one, right, the middle value is at 5. As for this one, the middle value is at 8. So for this distribution, they are having different spreadness and also different mean. Okay, this is one of the things that you can describe when you look at spreadness and mean. Okay. So let's talk. We already talked about the advantage and disadvantage, right, of all of this. Okay. So let's look at application of MCT and MD using empirical rule. All right, empirical rule is a kind, we can say that it is a rule of thumb in statistics. So given a certain situation, okay, you can actually predict how much data that you have in certain percentage. Okay, so let's look at what does it mean by that. Okay, so before we talk about this, let's go a bit on maybe discuss on how to interpret measure of dispersion. So for this one, as you can see, they calculate the variance and standard deviation of external diameter, which is the first example that we used just before. So if you see the mean here, right, the mean here is 3.001, which is, we can say that the middle, the center point for the data is 3.001. As for the standard deviation is 0.4047. So how do we actually explain these two values? That is what you need to know. In statistics, this is how you use it. You use MCT and MD together. So this is how you write it down. You have mean plus minus standard deviation. So for this case, you have mean of 3.001 plus minus standard deviation of 0.047. Okay, so the things that you need to know. What is this? How do you explain this? Okay, so just look at this operation in the middle, which is plus and minus. So in other words, you need to plus and minus these two values. So if you minus, right, 3.001 minus 0.047, and later you plus 3.001 plus with 0.047, you will get this range. So what does this mean? So any what does this data talks about? External diameter, yeah. Any external diameter, alright, within this value, which is 2.954 until 3.048, right, we can say that, right, it is kind of standard, right? So if you have the measure of external diameter of your data within this range, we can say that it is normal, right? It is standard, don't worry. So how about if you have the data that is outside this range? In statistics, we don't just have one mean and standard deviation formula. We have the second one is 2S, and the third one is 3S. Right, 3S. In other words, right, we there's a spreadness that information on spreadness that you can see for if your data is is 0.047 from mean, which is you'll get this range, or maybe 2 times, right, from 2 times of this value from mean, and 3 times of this value from mean. If we look at it specifically, you're going to see that, right, if you are just comparing the standard deviation from mean, right, one standard deviation, this is the range that we get before. Okay, if you are comparing standard mean as two times the standard deviation, right, the value of 2 times the deviation from mean, as you can see, the spreadness become the range become wider. Okay, right. If you are comparing to 3 times the standard deviation, the range will become a lot more wider. So depending on actually how do you define normal for your data, right? This is actually being used in a company. They even go for 6 standard deviation to determine the spec of their product is normal and should not be rejected. So if let's say that 3 standard deviation is acceptable, so for this case, for the external diameter here, let's say that they are saying that the spreadness of 3 standard deviation is okay, still okay. So any product that is that has external diameter within this range will be accepted, right? For those outside this range, maybe 2.1 or 3.2 will be rejected. That is how you use the spreadness, the dispersion. You compare it with MCT here, which is the mean. Okay, so we're going to talk about empirical rule that I touched earlier, right, in the next video, that is also related to this. Okay, thank you.